Hello everyone, my name is Wendosen. We are going to start the next chapter of chapter 1, the next continuation of what we did last time. Today we're going to discuss about the different types of measurements. I would like to start with exact measurement. I'm sorry for my handwritings here, it's a little bit not that much perfect. And then the second type of measurement discussed is measured numbers. And exact numbers. So instead of saying measurement, I will say exact numbers. So we're going to discuss about two of the numbers, and later on we're going to see about something of dimensional analysis, and we're going to see how we convert one unit from one unit to the others. These are the three things that we're going to discuss in this video. What are exact number? I can give you a very simple definition of exact number. Let's say that if you count the number of students in your class, okay, exact numbers, if you count the number of students in your class, how many boys and how many girls are in the class. If you say there are 10 boys and about like 15 girls, in type of measurement, this is exact number. It's called exact number. Or if you count how many test tubes you have, in your lab station, how many test tubes or beakers or graduated cylinders you will have in your lab station, this is going to be exact number. So you may say like there are about 6 test tubes or 10 beakers of different sizes. You may have a graduated cylinder, maybe 3 graduated cylinders. Okay, so this basically is considered to be exact number. So I think exact number is pretty much simple and easy to explain. Measured numbers. What are measured numbers? So measured numbers are numbers that you use different tools or instruments. Okay, if you like to measure length or width of a table, the length and the width of a table, you basically need to have a ruler. Okay, so whatever number you get, that's called a measured number. So let's say that the length of a table, a regular table, might be 7.5 centimeter, and the width, this is going to be the length, and the width would be let's say 4.2 centimeter would be the width. So this is going to be measured number. I'm going to go to the next slide. Bear with me for a little bit. So we're going to continue with the next slide about measured numbers. Measured numbers, like I said, is something that you use instruments. You need to have instruments. So one of the things that we need to know about measured numbers are not always accurate. They are not always accurate. Accurate or accuracy. Accuracy means that if your measured value, if the measured value is closest to the true value, or you can say the standard value, that's called accurate. And the precise, we're going to use the terminology of accuracy and the precision when we measured some objects. So precise means that let's say that if the measurements are close to each other, they don't have to be accurate, but whatever measurements that you do, if the measurements are close to each other, we can say they are precise. Close to each other, so that's precise value. So when we are dealing with measured number, we have to look these two terminologies, whether our measured number is accurate and precise. So in most cases we do measurements to avoid mistakes or errors. I would say errors. When we say errors, there's going to be human errors. There's going to be also instrumental errors. Human errors actually comes from human perceptions. I'm going to write down here perceptions. Instrumental errors comes as mistakes from the instruments, maybe like the instrument when is not calibrated, the scale is not calibrated very well, or it might be old, so there is a calibration error. Instrument can be old. Okay, so these things will take into consideration. So we will have the human error, we will have the instrumental error. So when we do measured number, we basically have to use maybe like 3 times or 4 times to avoid errors. So we also need to know about, a lot of times students have problems in terms of identifying significant figures. I'm going to talk a little bit about significant figures. What are significant figures? Significant figures are numbers that we report when we do measurements. These are numbers that we report when we are dealing with measurements. When we do measurements, all the numbers, let's say, I can give you an example. We will have 4.075 centimeter. Now in this case, this is a length of some object, and we will have basically 4 significant figures here. Significant figures will become very tricky, especially when zeros are involved. Sometimes zeros are considered as a part of measurement, sometimes zeros are considered just as a placeholder. I'm going to explain about the zeros, whether they are part of measurement or placeholders, in the next slide. Bear with me. So significant figures, like I say in the previous slide, significant figures are all the numbers that we report when we do measurement. We will have let me give you some example. Let's say we have 0.0005 centimeter. Let's say we have 0.205 centimeter. Let's say we have 1.004 meter. Let's say we have 1,000. This 10,000 meter. Now in this case, I just pick the zeros, or let's say let's pick a non-zero number. Let's put 2.07985 centimeter. So we're going to see whether the zeros are a placeholder or the zeros are parts of measurement. In this case, the number of significant figure we have is only 1. The zeros that are mentioned here are not part of measurement, they are placeholders. If you have zeros in between of the non-zero number, it's considered as a part of measurement, so you basically have 3 significant figures here. This is also the zeros included with the non-zero numbers are parts of measurement, so we basically have 1, 2, 3, 4, 5 significant figures. I'm going to write 5 here. Now this is in most cases is ambiguous. This can be 1 significant figure, or this can be 5 significant figures. It can be 1, or it can have 5 significant figure. So it's a little bit tricky here how we can able to identify whether this one has 1 or 5 significant figure. One way to identify that, if you like to rewrite this number as 1 significant figure, you may have to use a scientific notation. Maybe you can say 1.0 times 10 to the power of 1, 2, 3, 4. If you say 1.0 times 10 to the power of 4 meter, always remember that units are very important. Now in this case, basically, since you have the decimal point here, 1.0 times 10 to the power of 4 meter, this will have 2 significant figures. Okay, after the zeros point are parts of measurement, we have 2 significant figures. Okay, let's say if you just would like to have only 1 significant figure, you just say 1 times 10 to the power of 4 centimeter. This time you'll have 1 significant figures. Okay, so it depends how many significant figures that you like to add. Let's say you like to have if you put 1.000 times 10 to the power of 4 centimeter, all the by the way, these numbers here, they are called as coefficients. So these numbers are part of measurement, and the coefficients are part of measurement. So in this case, you will have about 4 significant figures. Okay, this is how we count significant figures. Remember, we don't have significant figures in exact numbers, but we will have significant figures in measured numbers. Okay, let's go to the next slide. Bear with me. So now we're going to see about the applications of significant figures. What is the application of significant figures? When we deal with the applications of significant figures, we have to able to break down into the order of operations. We have to see multiplications. Sorry, here multiplication and division come in one line, and we'll have addition and subtraction will go to the other line. So let's say that we have a dimension of a table that has 4.5 centimeter multiplied by 6.7 centimeter, and we'd like to know its area. Okay, so I have I'm going to use my calculator here, and I would like to multiply 4.5 times 6.7. It's a simple mathematics. The calculator display would give me about 30.15 centimeter square. Now you can see from here that you'll have 4 significant figures, but the original numbers would have 2 significant figures. So we always need to we wanted the final answer, which is 30.5. That's our final answer, has to reflect the original of the major number. The original of the major number, both of them have two significant figures. So how do we bring 30.15 into two significant figure? That's going to be 30.2 centimeter square, but still it has three significant figures, so most likely this would be 30 centimeter square into two significant figure. But technically, if you put 30 centimeter square, someone might say the zero might not be a part of measurement. So the best way to address this is you can write 3.0 times 10 to the power of 1 centimeter square. If you write this way, one can easily tell that this one has two significant figures. This is how we apply significant figures. If you have questions about to know more about significant figures, after the video there is a comment tab. Please send me your comment. I'll be happy to add more examples about significant figures. I'm going to move to the next slide. So the next thing is we're going to use some of the calculations in chemistry. Once we learned about significant figures, let's do some calculations. One of the things that we do in chemistry is to identify density. Density is one of the physical property, by the way. It's a physical property. What is density? Density equals to mass divided by volume. In most cases, in most literature, they don't want to write mass over volume. They write an abbreviation for mass is like M, for volume is V. So once we know density equals to mass over volume, we can able to make some kind of deduction from the original formula. We can calculate mass equals to density times volume, or the other deduction is that volume equals to mass over density. So you have three relationships here. You have this, like I'm going to put number one here. This is the original one, which is density is mass over volume, mass equals density times volume, and volume equals mass over density. And density, what's the main purpose of density? It helps us to identify substances, help us to identify substances. And also we have to take into consideration that density is called density is a physical property. It's called something called intensive physical property. Intensive physical property. Intensive means that the amount of density doesn't change. Let's say you want to measure the density of 5 liters of water, okay, or you want to measure the density of 5 milliliters of water. As far as it is water, the density is going to be the same. It doesn't change. So it's pretty much anywhere between 0.99 to 1 gram per milliliter. That's going to be the density of water. For 5 milliliter, it's also the same value. We get 0.99 to 1 gram per milliliter. So such property, we call them intensive property. By the way, density is one example of intensive property. We will have also, like, we can add freezing point, boiling point, melting point. All these are examples of physical property. I mean intensive physical property. Something like mass or volume or pressure is also considered as extensive physical property. When you change the mass or the volume or the pressure, also the property is going to be changing. But in terms of intensive physical property, it doesn't matter how much of the substance that you have, um, it doesn't change. Like I say, the boiling point of water is 100 Celsius. It doesn't matter whether it is 1 liter of water or 1 gallon of water, still its boiling point under normal circumstances is going to be 100 milliliter. I'm sorry, it's going to be 1 gram per milliliter. I'm going to move to the next slide. So now we're going to see, let's do something here. So we're going to see some calculations of density here. Some calculations of density. We know what density is. We know the formula for density is. We know the density is intensive physical property. Let's say how we can able to do some calculation. So let's say I have a sample of magnesium. I would like to work with magnesium. Magnesium is one of the metal in the periodic table. It is belongs to we call them alkali. We call them alkaline earth metals. Maybe we can discuss that later on in the next videos. It's one part of the alkaline earth metal group. Let's say the mass of alkaline earth metal or this magnesium would be like 15.7 grams. And then the volume of magnesium, the volume is, I would say, I just pick a number, would be 13.2 centimeter cubed, and then we would like to calculate the density. So the density would be like I say, mass over volume, which is going to be 15.7 gram over 13.2 cubic centimeter. Remember, units are very important. So when we do the calculation of 15.7 divided by 13.2, that will provide you, okay, my calculator display shows me about 1.18939 gram per cubic centimeter. Do you know how many significant figures you have, by the way? There's a point here. 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. There are 9 significant figures. Okay, now we're not going to write all these 9 significant figures, so we have to minimize that into 3 significant figures, 3 sig figures, right? In order to do that, we have to basically round it up, this number, and we basically come up with 1.19 gram per cubic centimeter. Remember, the reason why we need to round it into 3 significant figures is that the original numbers also have 3 significant figures. If you look here, you have 3 significant figures. If you look here, you also have 3 significant figures. So we're going to do more calculations in the next videos. Please bear with me. Thank you very much.